Okay, guys, so let's start our today's session. Before we continue, what we discussed in our previous session, let's revise, right? Uh, so much of content we gone through. I think I need to draw the diagram again. All right. So please guide me and help me here in doing that. So today we are talking about a few other additional components. This is our SGA, right? So components, SGA components. Already started discussing about the background processes, right? DB writer, log writer, checkpoint, SMON, and we also got one more PMON, process monitor. So we already discussed about few data files, like one is our system.dbf. Then we have another one, undo.dbf, and one more is users.dbf. Redo log files, yep, that too. We got two redos. One is redo one dot log. I can give redo two dot log. And we got a control file. Yeah, what is the name? Control 01 dot ctl. Database writer DBWR. I hope the text is visible. LGWR CKPT system monitor SMON process monitor is PMON. So DB writer invoked on n number of cases. What are those? Can you please help me here? What are those? DB writer invoked on. Don't see. Invoked by server process, threshold limit. Another is checkpoint process. Log writer is invoked on n number of cases. What are those? Whenever you issue commit one third full, and another is 3 seconds. Correct? 3 seconds. Checkpoint is invoked on n number of cases. What are those?
DB writer.
No DB writer. Checkpoint invoked on what cases? One is a log switch.
Right, log switch.
Whenever you make your database a shutdown. Whenever you make your table space or data file, right? Read only or offline. And there is one more. What is another one? Fast start MTTR target. I'm writing all short keywords here. So please be with that. Is that correct? So SGA, all right. We discussed the shade pool. We got library cache in it. Data dictionary cache or cache. Redo log buffer. Buffer cache contains two lists. What are those? One is LRU list, another is a checkpoint queue, right? Correct. We have different statuses of buffers. Okay, leave it that one. What are these in the redo log buffer? Redo entries. What are these called as? Redo. What are these? These are redo entries. Correct. SMON part also we covered up. What is SMON doing here? One. Tell me, guys. Instance crash recovery. Instance crash recovery. SMON. Right. These are the components we discussed till now. Now, what more?
Checkpoint initiate two process. One
checkpoint. Call. What checkpoint will do? That is one part. What DB writer will do whenever invoked by this? Take dirty buffers and flush out. Yes. Log writer will take the redo entries and write to the redo log files. Checkpoint, whenever invoked, it invokes DB writer and then updates each data file header with a new checkpoint number
Number
and the same is recorded in your control files.
5.
Right? That's what actions they do. SMON, what it is doing, it is responsible for doing the crash recoveries during the instance startup action. Yeah. Any questions, please, in this? Any questions, doubts, queries you have? Yes, no, let me know. When you submit a statement, a select statement, server process, first, where it is going to do a check? Question for everyone, guys.
First, it will go to the L3 to check any cursor is having a cursor equivalent to that.
So it is going to where? It is going to the library cache or cache. It's going to the library cache to check the statement is already executed and the plan available or not. If it is not, then it will go and do the parsing and execution. If not, if it finds it already there, it will simply reuse it. Correct? Yeah. And after getting the execution plan, where it is going to perform a check again. The second check it is doing in the buffer cache because I got a plan. Plan is what? A table scan or an index scan. So I have to check those blocks are already there in memory or not. If not, I'll go and bring from the disk. If they're already there, I'm simply reuse. Got it? Right. Okay, let's start with our today's part. Right? So much of content we have again in this session today. Let's start. One, with every connection, a process we got here on the server. What is this process name? Server process. On the user end, what is the process? User process. User process, a server process. Yeah, we got. Next. With every process, some memory gets allocated. What is that? Memory gets allocated. This memory area is called as PGA. What is this? PGA. So we actually call it as a program global area, right? We call it as a PGA. A PGA is a memory area with process. Not only here, even if you look at your Windows Task Manager, you see so many processes running. With every process, some memory gets allocated. Some memory gets allocated. Getting my point? Yeah. Now, example, you opened a notepad or a Word document. You see that Word.exe process created, a Notepad.exe background process created, and some memory gets assigned or allocated to that process. Now, whatever you insert, right, you are going on writing data or copying some content from here and there, right? As you start writing data in that, what happens? Where this data is actually stored? Somewhere it has to store it, right, temporarily. Have you saved the file? No, we haven't saved. So even though you don't save the file, no worries, but temporarily it has to hold it where? The memory area. As you go on writing data or inserting data in the document, you just check out the process in the task manager. The size of memory allocation also grows. Size of memory allocation will be growing there, right? Yes. So now, right, memory allocation grows. Same way, like in our OS, right? In database also, with every connection, some memory gets allocated with the process that is called as a PGA. Now you got already some processes running in the background. We call them as background processes, a set of. Now each process, obviously each process going to have that, what is that memory area? PGA. With every process, you got some memory allocation called as PGA. Get it right? With every process. Yeah. We call it as a PGA, program global area. Now these processes, they keep their own internal information in them. We are not nowhere concerned about it. Leave it to the Oracle, whatever they want to keep. Now this is the one where these are related to me because the users are connected to my database and these are the processes who are going to run the queries on my database. Correct? So I want to know about this. So this PGA, what you see with your server process is mainly divided into 1, 2, 3, 4. Mainly into 4 parts. One, a small area of the PGA where it keeps its own information. That area is called or used to store session information. What is that? Session. Now, this is a session or a connection. Now, for another user, there is another session, right? Every connection, a session. It keeps its own information. The connection is from which application, from which IP, how long it is running, like that internal information it will keep. Some area of my PGA is used to store that information. Next, we got another section here. What is this? This section is your used to store bind variables. What are these? Another area is used to store bind variables. Now, what is this bind variables? Variables in SQL, PL SQL, you might be knowing. SQL part you would have done. Yes or no? Remember? No. Okay, what is that? You might say select star from EMP where employee ID equal to ampersand ID. Ampersand ID. When you enter the statement, it will ask you the value. Please enter the value for what? ID. Now you are going to enter some value, example 101. You entered. So that 101 is assigned to what? ID, because wherever ID is referred multiple places, that is nothing but going to be 101 in that case. So somewhere it has to store that information. These are called variables, right? The variables in this. So whatever the values you enter are passed to this variable that to be stored, it uses this area. What is this? Another section area called as bind variables. Now the another one more part here, this is our sort area, and the another one is cursor stack. Another one is a so my PGA is mainly divided into 1, 2, 3, 4 session information, bind variables, sort area, and one more is the cursor stack. I hope you understood session information, maintaining its own information about the session, that is for internal purpose, fine. Bind variables, all your users when you submit the query, if any variables are there, right, and whatever the values you pass it, those values will be stored. So variable values, everything is maintained. So some memory is allocated for that. Correct. Next, the another biggest area, this is actually the bigger area here, the sort area, and one more is what? Cursor stack. I'll come to the sort area later. Let me first discuss what is this. Now, somewhere already we discussed or talked about cursor. Where is the cursor in our architecture? Please, anyone? Huh? Where is that? Library cache. Correct. In library cache, we got what is that? A cursor in which what we have? Our statements, parse code, and execution plans are stored. A memory area chunk located. Correct? And I asked you the first question, what is that? When a statement submitted, my server process will do first check where it is. The first check it is going to do in the library cache for what? Do you have the same statement already there or not? It's going to check. Make sense? That's what. So now, again, just think again, guys. Library cache, how big it is? I told you, it is in couple of GBs. MBs are GBs, huge. That means there are so many cursors, hundreds, thousands, millions of cursors you will have in the library cache. Correct? Now, right, logic. What is the logic? Whenever you submit any statement, server process, what it is doing, please repeat again. Server process, what it is doing? It is going to do a check where? It is going to check in the library cache, do we have statement or not? Correct? Now, checking in the library cache, where thousands and millions of cursors are there located, it's a time taking process or not? Got my point? Okay, example, man. I'll give a small example. Let's say my friend called to me, a neighbor called to me, Akal, next to your office, there is a school. Can you please just, if you have some free time, can you please go to the school and just check, do we have their kid, right, is there or not in the classroom? I said, okay, fine, I'll go. I have some free time, let me go there. I went to the school. There's so many classes are there. I can't go and search where it is. I'll just call him which classroom. Oh, it's the 3C. Okay, let me go to the third class. Okay, I just went to the third class and I see it's a big room, hall, and there are nearly 100 kids are playing, are sitting there in a classroom, big one, 100. Okay. So now I'm just searching, where is that guy? Where is that guy? Where is he? Where is he? Where is he? And finally I found, yeah, he's sitting in that corner, or might be he's sitting in this corner or somewhere on the chair. It took time for me to find he's there or not. The more the people, it takes more time to find. Yes or no? Simple logic. Yeah. So imagine same, the library cache is really huge and there are so many cursors. So obviously it will take some time. Could be millisecond, nanosecond, or a fraction, whatever the second is there. But some time you're spending on finding that the cursor is available or not, or the statement is already readily available or not, taking time in searching. Got my point? Same way, I scanned the class. It took few seconds for me, and finally I found where he's sitting. And teacher also told me, Akal, sorry, no problem. He always sits, that is his bench allotted. He will be sitting always there. After a week, he called me again, my friend. Akal, please, can you just go and check, is he there in the class or not today? Fine. Now, do I need to scan the whole classroom again? No, I have that information. Teacher also told me he's there. I know where he's sitting. So simply I'll just focus there and immediately I found. I avoided the scanning of the whole class because I know where it is available. Correct? Because the last time when I went, first time, that's the first time, last time nothing but the first time when I went, I did the whole scan and found where it is. Right? But second time, next time, I no need to scan every time because I know where it is available. So I can directly go there. Correct? The way we keep our information in memory, local in my memory, right? Same way in your server process, what it is doing, it is going to scan. After scanning, it found this is the cursor because there are so many cursors are there. It found that which is the cursor, this is the cursor related to the statement. I found it. Now what happens here? Your statement and the cursor address is maintained locally within, what is this? PGA of which process? Of this server process. The way I'm having that information. Next day, if he calls me another friend and he goes again there, he need to again scan. If he calls me, I know where he is available, right? Same way, this server process, PGA, now he knows the statement. This statement, there is already a cursor available in the library cache. The address is maintained. The good thing here now, I'm just trying to reframe my statements, right? Now what happening, whenever you submit any statement to the server process, please guys here, right? First, it is actually going to check where? It is going to check in the cursor stack, right? Because whatever the statements you submitted, the statement and the cursor, if the cursor got created, even though it is the first time, right, created, the address is recorded. Okay, there is something I missed in my previous sessions. Let me add here. Parsing, the day one we discussed. Parsing, correct? So your parse code execution plan available, right? What happening now? Whenever you submit a statement, I will go and scan the library cache and I'll check if I found the cursor. I'm going to reuse the parse code and again reuse the execution plan. Done? Is it I'm generating or doing the what we call parsing the statement again? No, right? I'm not reparsing the statement. I'm simply reusing the code. This is called as soft parse. Called as soft parse. Within parsing, there are two types of parsings are there. When I say parse, parsing should happen, must happen. the syntactic semantic check must be done. But again, within that there are two types. One is called as a soft parse. What do you mean by soft parse? I found a cursor and I am going to reuse the available parse code, that is called as a soft parse, right? If it is not available, I didn't found the statement, then what I will do? I am going to do the again actual parsing, where I might need to load some metadata. Using that, I have to validate syntactical semantic checks. Is all time taking process with IOs and all. That is called as hard parse. One is a soft parse, another is a hard parse. Two types of parsings. Which one you prefer better? Obviously soft. But remember always, when you start up your instance first time, what happens? All these memory components are free. There's nothing, no data in them. And whatever the statements comes in, by most of them, they're all for the first time, all of them has to go through hard parse. But over a period of time, couple of minutes, hours or days, automatically most of your statements will be available here. So you need to ensure that most of the time your queries are going through what parse? Soft parse, not the hard parse. If there are many hard parses are happening compared to the soft parse, the ratio is high, then probably one reason could be the memory area is very small, the cursors are getting overwritten very fast. If it is very small, it is getting overwritten very fast. So better increase the memory area so that more cursor can be there, and the first cursor can be there for very long time, so that if we resubmit the same statement, it can be reused. Got it? Okay, so another tuning, that's a part of tuning, where soft parses you have to ensure they are always more high compared to the hard. Done? Now, understood the soft parse. What do you mean by soft parse? Finding the statement in the library cache and reusing the parse code. Reusing simply, correct? But now finding means again I have to search the library cache and find it. That's a time taking process. Right? Okay. So what Oracle is doing, it is trying to keep it locally within the PGA inside the cursor stack. If I submit the same statement again, I will check out here. Hey, do I have already submitted the statement earlier or not? Yeah, I found here. So what is the address? This is the address. Which one? This is the cursor. The server process will directly go to that cursor and simply use it. This is also a soft parse, and faster or not? Faster. No need to scan everything. Simply directly go to the cursor and take it. Makes sense, guys? Understood? I'm sure that most of the DBS or many DBS, most not, many DBS might not be aware about these terms or concepts. Right? This is all theory part, concepts. Until as you read, right, you won't get. So please be with me. Understood now? So how many statements and how many cursors, so that depends on it. There is a parameter through which you can set how many cursors. These are all cursors, right? How many cursors information you want to keep in this. The more the information, the bigger area it required. Less, right? Few. So there is a parameter called as open underscore cursors. Open underscore cursor, open underscore cursor is equal to a value. If I set it to 100, that means all my last previous 100 statements and cursor addresses are maintained. If I keep it to 10, only last 10 statements and their addresses are maintained. So what happening every time when you submit the statement, remember guys, first check is happening where in the cursor stack always. Locally within the PGA. Hey, do I have the statement already earlier executed? Do I have any update? If I have it, I can directly go there, which is actually helping you to avoid scanning the library cache, which is much more better. That's the reason we have local. First check in the cursor stack. If it is not there, then what I will do? Second check. Where is the second check happening? In the library cache. Even though you didn't found the statement in the library cache, then it will go through hard parse. It will go through the hard part. Please. Right? So PGA, right? The area, small area section used to maintain session information. The next is bind variables. The next last one is cursor stack, which is controlled by a parameter open underscore cursors. Cursor something. Okay, cursors. The next one biggest area in the PGA is what is that? Sort area. Now, what is this sort area? Sort area is a memory area of your PGA related to whom? Server process. Now, the query is somewhat like this, might be few columns you are selecting, whatever it is. Select start from EMP. EMP, I'm going to say order by what is this? Now, if you go to the table, the blocks, whatever I have, which contains the rows. So what happens if it select start from there is no where condition? If there is no where condition, what? Full table scan or index scan? Full table scan. There is no where condition at all, right? So obviously you are trying to read all rows, but I want those rows in what format? Order by salary. So full table scan, the entire table is loaded into the buffer cache. After loading, take the values, arrange them in order. Correct? Yes, arrange them in order and then return the values back to the user, because the data whatever stored here, it is not in the order format. But I want the output in what format? Order format. You might say group by. Correct? You might say some group by. Select what we call a department number, comma sum of salary, group by department. I want to say department 10 total salary, department 20 total salary. So it need to take the values, calculate and give you the result. So the way you are requesting, the data is not available in the table. It need to take the values, arrange it, and then it has to give you the result. So to do the processing of your data, that's called processing, working with your data, ordering, group by, sum of, what are the functions applying, it requires a area, a memory area is required. Simple man, I'll give you two words. 6, 16, 9, 19. Can you please arrange it in order? 19. Right? What four numbers? 6, 16, 9, 19. 1, 9, 19. What is that? 6, 9, 16. Now, how you loaded? How you did? You took these values, kept in your memory, processed, and gave me the output. Are you using memory or not? Even you remember what are those numbers? Yes, it is there in memory. Right? Okay. I'll give you another example. Let's say 5 plus 15 into 3 minus 12 plus 36 into 4 minus 10, right? What is another one, like into 5 plus 20? Can you tell me what is the result? Difficult, right? But can we get the answer or not? Yes, we can get. Normally mathematics exams or tests, what we do, we'll have a rough paper kind of thing, a rough page. You're asking total, I will do. What is the 3 plus 5 plus 15, how much? 5 plus 15, 20, 20 into 3, 60, 60 minus 10, let me keep it as a 10. How much? 50, 50 into 30, 80, right? 80 into 4, 320, 320 minus 10, 310, 310 into 2, let me keep it 2.
620.
620, 620 plus. So somewhere 640. I got the answer now, right? But I need this area. Yes or no? I need this area to do all this calculation. This is like a rough area, what we call. And once the results are given, right, I don't need these values anymore. That's why normal in mathematics, accountings, right, we'll have maintain a rough paper kind of thing. We'll do all calculation or we use calculator, do it. And finally, answer we are going to write. A temporary area required. Why? Because everything I can't do it in my memory. My memories are not big enough. Right? Understood, please? Same way, if it is a small amount of whatever the amount of data is here, so what happening here, memory is used, please understand. So these blocks are taken here, arranged in order, how it is going to load this data into this, what is this? Sort area. It will load this data into the sort area in memory. This is in memory, like 6, 9, 16, 19. Correct? Right? In memory, and then it is going to process and returns you the data. So like this, for any queries, if you have order by, group by, sum of, many more other functions applied, the data is taken and loaded into the sort area, processed and given to you. So this way the sort area is used. Sort area is used. Yeah, Gurvinder, can you please mute your mic? Yeah, Gurvinder, any question?
Once the server process is over, that cursor stack will also go away.
Yeah, this is related. See, the cursor stack and all this information related to only the server process. If the server process, right, is disconnected or gone or killed, what it may be, this information is also gone. So whatever the information is here, it is not there with the other process. That other process will have its own information.
But is anywhere it might be stored that this user has logged in and he.
It's all PGA is nothing but our personal memory kind of thing. Whatever I have in my memory, in my mind, I'm maintaining all the information. It is not with every one of us. We all have our local memory where we keep. It's not shareable. Correct? So same like that, PGA is also not shareable. It is all local, right? Available with your server process where this information is maintained.
But once a server process get created for a particular user, then this from where we can get this cursor stack area.
Again, please can you repeat your question?
Okay, let's suppose I logged in. I connected to my database.
You logged in your server process, there is no information. First time you fired the query, I don't have any statements available here. So obviously I'm going to check where in the library cache. After scanning the library cache, I found the statement available, right? Then I will, right, immediately record that information here in the cursor stack, that this is the statement and this is the address of the cursor, right? If it find, if I didn't found here, then server process will go with the parsing, actual parsing, execution plan generation, and after that cursor is created where it is stored, correct? Then after that it will go with the fetch operation. But before fetch, what happening, as the cursor created stored, now again the statement and that cursor address is recorded. So the cursor stack is used mostly for the recurring queries, not for the first time queries. If I resubmit the same statement again, then the query will be benefited with the cursor stack, because now it knows where is the cursor available. Got it?
Sure, thanks.
Yeah. Any other questions, anyone? Shall I proceed? Yeah. So session information, bind variables, session information, bind variables, another is a cursor, sort area, and the cursor stack are the components of my PGA. Now, sort area is the one term we are using. In older versions, there are multiple different areas used to be there, used for different purpose, like a sort area, what we call bitmap area, right? So different areas earlier. Now they are all just clubbed into one name term, one heading kind of thing, but used for so many different operations. Done? PGA, clear? Now, come back to this example which I took here. What is that? If the data is huge, all this data I can't load it into my memory and do the processing. Correct? It's not possible. So what we do, we require some rough area here, a rough page kind of thing. Then I will go part by part calculation. The results I am recording here, correct? And finally, once I got the total, I don't need this information anymore. Remote. I need a temporary area to hold the calculated value or outcome. Correct? Now, if the table is really very huge, a very huge table, so many blocks are there, right? Okay, huge table is loaded up here, so many blocks, right? And what I'm doing, I'm going to take this data, but I don't have enough PGA to accommodate the entire table. I don't have enough PGA sort area to keep all the table in it and process. Not possible. So what I will do, I'll take a portion of data from here. What I'm doing, I'm just taking a portion of data, some set of blocks, keep it here into the PGA and then arrange them in order, process it. Then once the done results, I'm going to write it into another object here. I'm going to write those results into another object. So what happens here? A new object is created. A new object created and this processed data is recorded, saved in it. Then once it is saved, then again I'm going to take the another set of data, take it into the PGA, again process and again write the outcome here. Next set of data, process one by one and write it here, write it here. Okay. Once the entire table got processed, it will take the data from here and it will return it back to the user. Correct? Once all this data is delivered to the user done, query output done, then it is going to remove this object event. It's no more required. So what I see here on the fly when query was submitted, as server process PGA is not enough to process the huge data. What happening? Right? It is creating a table called as a temporary table. What table? A temporary table is created and the process data it will start writing in it. So piece by piece, part by part, the table get loaded into the PGA sort area, processed and recorded. Once the entire table processed, now the data is taken from the temporary table and return it what? To the user process. Once this entire data is delivered, then the table gets automatically deleted. Understood? Yeah. What happened, guys? Fine, good. Shall I continue? Right. So like this, the temporary tables are created by whom? Who is creating them? Server process when the sort area of my PG is not enough to process the entire data. So right, temporary tables are created, data is recorded time to time in that. Once everything is done, the entire table processing done, it will take data from temporary and give it to the users, and at the end my server process is going to delete or remove the temporary table also. So on the fly they are created and also at the end of the query they are deleted. What are those? Temporary tables, temporary tables. So we got a separate data file for that objects, because you are not the one, there might be other user, they also running a huge query and their PG is not enough. All these users will go and use the create the temporary tables where in temporary data file, right? And once the queries are completed, done, they will delete, remove them. So free, again the space got freed. Makes sense, guys? Clear? Right? Yeah. Temporary objects came in picture. I hope you understood the sort area queries. Everything is working fine. This query is running. That means the temporary table got created and is in use, right? Before the query completes, the select completes, some problem came. Suddenly the instance got terminated. Sorry, the session got terminated. That means the process is gone. Process is gone. Some reason the process got terminated, disconnected, gone. There is no server process running. Or instance got crashed. The process, or not only this, all processes are gone. Correct? Next time when you say startup, what happens? Next time when you say startup, what happens? SMON comes in picture and do what? Crash recovery. It is trying to recover all your DML data, correct? But because of the selects also some tables are created here. Which tables we call them? What tables are this? Temporary tables. So SMON is responsible even. SMON is responsible even to clean what? Temporary tables during startup. It will check out, yeah, there are no server processes are running, right? And temporary tables are still there. So they are no more required, right? Let me remove the temporary table. So cleaning of temporary tables is also done by which process here now? SMON process when the sessions got terminated or instance got terminated any reason, right? SMON will take care of cleaning of the temporary tables. SMON will take care of cleaning. Is it done? Clear? Yeah. So SMON, two things mainly here. One is instance crash recovery, another is a cleaning of temporary tables. And now we got another set of tables, temporary tables. We have a separate data file for that. Undo tables we are creating in a separate data file, undo DBF. Users data we are keeping in a separate data file, and all our data dictionary objects are tables, data dictionary tables, everything base tables are in a separate data file. Fine, good. We also understood here now about the PGA and the components. PGA and the components already done with buffer cache, redo log, data dictionary completely done. The processes, these are done. Control file, redos, all the data files are nearly done. Correct? Yeah. Shall I proceed further now? Next.